www.kids.com. And if you like this video, don't forget to smash the like button and share this video with as many people as you can. And if you have not subscribed to my channel yet, kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today we are gonna learn about Singleton in Java. So I'm back with another Java topic, and we are gonna learn about Singleton classes in Java. And this is also gonna be a very interesting video. So without any delay, let's get started. Dab. Okay, so let's just start off, right? Start with the video. Okay, so in object-oriented programming, a singleton class is a class that can have only one object. So it can have only one object, meaning that you can create only one instance of that singleton class. So for example, you have a main class and then your singleton class. So you can only create one object of a singleton class in your main class, right? Because that's the behavior of singleton classes, right? All the other instances of the object that you create will refer to the first object that you created. So basically they will all point to the same memory location, right? So like over here we have the memory location in which we have our object saved, and then all the instances that you create, those really will point to the same memory location, right? So after first time, if we try to instantiate the singleton class, the new variable also points to the first instance created, meaning that if the new variable will get changed, then the previous one will get changed, and if the previous one gets changed, then the new one will get changed, because they are pointing to the same memory location. So for example, this okay, this is my sister's pen holder. So this is my sister's pen holder, and in this we have a lot of pens. So we'll take this as a memory location where we have a lot of pens. So let's just say that this pen holder, we have our object saved, right? So in this pen holder we have our object saved, and then we have two instances of the pen holder. Like we have a bottle instance, and we have just a headset instance, right? So they will point to the same memory location. So this bottle will also point to the same memory location, and this headphones will also point to the same memory location. And this is a terrible example. Okay, so just I have said about memory a lot in my previous videos also, so I don't think that I need to explain the references and all, because like it is that basically any other instance you try to create of a singleton class, it basically points to the first instance that you create, meaning that if the second instance changes, then the first one will change, and if the first one changes, then the second one will change. So whatever modifications we do to any of the variable inside the class through an instance, it affects the variable of the single instance created, right? And it is visible if we access that variable through any variable of the class type defined. So like you have a x variable and it is equals to an object, then your y variable will also point to the same x variable's object. So if y will be changed, then it will be reflected for x also, and if x will be changed, then it will be reflected for y also, right? Remember the key points while defining classes as singleton class, that is while designing a singleton class. First of all, you need to make your constructor private. You need to make your constructor private because whenever you try to create, you should not be able to, when you have your constructor private, you cannot create an object of your class the normal way. Like we create it like this, right? So like we do like we have a singleton class, it is named test, right? So, like any class we have, and it is named test. So we'll create its objects using a test x equals to new test. And when we do this, the constructor method is called automatically. But when the constructor method is called automatically, then because it is private, so if you try to and you are in any other class trying to create an object and it is private constructor, so it will not be able to be called because it has private access, or it can be only accessed in the class that defined it, right? And like you have a main class in that you want to create an object of a test class that has the constructor private, so you will do it like this: test x equals new test, right? So you'll do it like this. But this is not gonna work because because basically you are in some other class and you are trying to call the private method constructor, so that is not allowed to access the a private property of a class, right? A private method of a class or a private property of the class, so that will bring an error. So basically we need to make the constructor as private in our singleton class, so that we cannot basically create an object of that class the normal way we do. In the singleton class, we need to create an object through a different way that we are gonna learn, right? But we don't want it to do the normal way. So because if we are able to do it the normal way, then basically it will create new instances of the class, right? And that's not what we want in singleton's behavior, right? So write a static method that has return type object of this singleton class. So the second key point to follow is that we need to add a static method that will return us an object of the singleton class, right? So that's how we can get an object, and when we call that method, we'll get an object, and then we can save it in a variable as its value, and we'll get an object of that class, right? Without the normal way, right? So let us brief how the singleton class varies from the normal class in Java. Here's the difference in is here the difference is in terms of instantiation, right? So here the difference is in term of instantiation, right? As for normal class, we use the constructor, whereas for the singleton class, we use the get instance method, right? So for the singleton class, to create objects, we will use the get instance method, whereas in normal classes, we use the constructor that basically initializes all our properties and methods, right? So in general, in order to avoid confusion, we may also use the class name as the method. So instead of creating a get instance method, we can name it as the same as the class, right? So we can give it the same name as the class name, right? So basically when it is the same name, it will basically it will just reduce the confusion, right? So over here we have a first example with a singleton class. So Java programmed implementing singleton class with using get instance method. So we have a helper class over here, singleton class, right? So static variable reference of single instance of type singleton. So over here we are creating a private static variable, and its value is of singleton type, and its name is single instance, and its default value is null, right? So it is an empty value by default. So declaring a variable of type string. So then we are declaring public string s, right? Now we have our private singleton method. So this is our constructor. Here we will be creating private. Here we are creating a private constructor restricted to the class itself. So basically, over here in this, we are just setting the value of s to hello, I am a string part of singleton class, but we cannot. This will not be called, right? So this will not be called. So this will not be called because basically it is private, right? So if we try to call this, if you try to create an object the normal way, then it will call the constructor method by default, and because it is private, it will lead us to an error. Now we are creating our get instance method, right? So it is a public static method. It is it will return us a singleton data type value. So basically this is saying that it is returning an instance of the singleton. It will return us a instance of a singleton class, and its name is get instance, right? And we're checking if single instance is equals to null. So if its value is null, so single instance equals new singleton. So we are creating a new singleton object and setting it, giving it to single instance, and we are just returning single instance. So basically, whenever we call this, we can save the value somewhere. So now see, when it is not null, right? So when the object is not null, then it is the previous object, right? So it's a previous object that is set as the value of some other variable, and then once we return it again, then that is the same object that we are returning, right? It is the same object, right, that we are returning, completely the same object. We are not redefining it, right? We are returning the completely same object. And then if we try to save it in some other variable, then logically those both are the same objects, meaning they point to the same memory location, because this once this single instance is defined and we return it once again, it is saved in one memory location. Because we are not redefining it, and because we are not redefining it, it is saved in one memory location. And whenever we save it in multiple variables, they all will point to the same memory location, right? So let's see. So in our main class, we'll see this in action. So in our main method, we are creating an object of a singleton class. Its name is x, and we're just calling singleton.getInstance. We are able to call it like this because it is static, right? So this is returning us, because first of all, single instance value is null, so it is creating a new singleton object and setting it as a single instance, and it is just returning a single instance. So over here we'll have an object of singleton, right, of the singleton class. And then we are creating a y variable, and that will also contain an object of the singleton class. And basically singleton.getInstance, we are doing singleton.getInstance. So now it is not null. Single instance was not null. It has already been given a value. It has already been assigned to a value, right? That is an object. So because it is not null, it will go outside and will run it. It will return us the single instance, right? So now basically nothing has changed. That object that was there, it is still in that memory location only, and that object is only returned, and we are saving it in x also and y also. So x and y are pointing to the same memory location, but because that object is never being changed, right? So x and y are pointing to the same memory location because they are getting the same object, right? And that's why whenever we'll change x, y's value will also be changed, and whenever we change y, then x value will also be changed. Then we are creating another object of singleton that will still point to the same memory location, and its name is z, right? And we are doing singleton or get instance, so it will just return the previous instance only, right? And then this z also is pointing to the same memory location. So x, y, z, three variables are pointing to the same memory location. So if x is changed, then y and z will be changed. If y is changed, then x and z will be changed. And if z is changed, then x and y will be also changed. Then what we are doing system.out.println hash code of x is x.hashcode. So we are taking out the hash code of the three objects, and because they are the same objects, it will give us the hash code will be like the hash code will be the same, right? And we are checking if x equals to y and y equals to z, and that is true because they are pointing to the same memory location. Then it will print out three objects point to the same memory location on the heap to the same object. Else, if this is not true, that is not possible right now, right? We can clearly see that this statement is true, but if it is not true, it will just say three objects do not point to the same memory location on the heap. So over here it will just show hash code of x is some hash code, then hash code of y is the same hash code that was before, and then hash code of z is the same hash code that was before, and it will just show us three objects pointing to the same memory location on the heap because they are pointing to the same memory location. So we are seeing hash code of x, then hash code of y is also the same, then hash code of z is also the same, and we can see three objects point to the same memory location on the heap to the same object, right? Quite cool. And this was also a very interesting code. We'll just comment this out and then move on. So in a singleton class, when we first time call get instance method, it creates an object of the class with the name single instance and returns it to the variable. Since single instance is static, it is changed from null to some object. So if you have noticed, single instance was static. So that's why we were able to change its value and work with it, right? So um it creates an object of the class with the name single instance and returns it to the variable. Since single instance is static, it is changed from null to some object. Next time if we try to call get instance method, since single instance is not null, it is returned to the variable instead of instantiating the singleton class again. And because it is not instantiated again, it was the same object, so y also received the same object, and that's why these and because they both were pointing to the same memory location, so whenever x's value will change, y's value will be changed, and whenever y's value will change, x's value will also change. So it is returned to the variable instead of instantiating the singleton class again. This part is done by the if condition, right? So in the main class, we instantiate the singleton class with three objects x, y, z by calling static method get instance. But actually, after creation of object x, variables y and z are pointed to the object x, right? So wherever x value is saved, to that memory location only y and z are pointing to, right? So hence if we change the variable of object x, that is reflected when we access the variable of objects y and z, right? Also if we change the value of object z, that is reflected when we access the variables of objects x and y, and whenever we'll change y, that will be reflected with x and z too, right? So now we have our second program. So Java program, now we have seen the get instance method. Now we'll see instead of get instance, we can keep the name as the class name only, right? So let's see. So we have Java program implementing the singleton class with method name as that of the class 1, right? So here we have the helper class, singleton class. In that we had our single instance. Like before, we have a string s, we have our constructor that is private, and it is setting x to hello I'm a string part of singleton class. And then in a singleton method, now instead of get instance, it is singleton, right? So because we can name it singleton also, right? So we can name it as the class name also. So now a singleton, the method that is creating a singleton object is basically named singleton only, and in that we have written our same code. And in the main class, in our main method, we have a singleton x, right? We are creating these three objects that are pointing to the same memory location. And see, instead of calling the get instance method, we are calling the singleton method, because this method is only returning us our object, right? And it will not call this method, right? Because it knows that this is our constructor, and it also knows that this is our normal method. How it knows that? Because we have given it a return value, which type should it return, and second of all we have given the static keyword, right? So both of these can't be there in our constructors. That's why it knows that it is a normal method. right? So we are calling the singleton method, and it is first of all creating a new object over here. Then y is pointing to the same object and z is also pointing to the same object. And then what we are doing, we're doing x dot s equals x dot s dot to uppercase. So this is interesting. Over here we have done public string s. Before, what we did, we did public string s. Okay, sorry. So over here we have a public string x s, so we can now use it. We can do x dot s equals x dot s dot to uppercase, so it will convert all its letters to uppercase. And then if we just show x dot s, we'll get all the letters in uppercase. When we show y dot s and z dot s, they will also come in uppercase. We know why, because it is pointing to the same memory location. So if any change is there in x, it will be reflected in y and z also, and meaning that if any change is there in the x's value or in one of its properties, then also any single change, property, method, or any change, that will be reflected in the other classes also. Then we are just printing out a new line. And then what we're doing z dot zes equals z dot des dot to lowercase, and then we access all three of the s variables from all three all three objects that are pointing to basically all three variables that are pointing to the same object. Then also we'll see that the change is reflected in uh, all the s strings, right? So over here, when we were changing x's value, then also the changes were reflected in the other two variables, and when we change the z string, then also the change will be reflected in the other two variables also. So first of all, we'll see string from x's all capital hello I am a string part of singleton class. Then we'll see the same result, but it will show single string from y is the same result as here. Then string from z is the same result as these two. And then we are doing lowercase, so we'll get everything over here that was in lowercase, right? And we are seeing double lines because we added a new line also, and print line automatically leaves a line also, right? And as we expected, we are getting the result, right? So yeah, this was it, guys. This is how you can create a singleton class, and I hope you guys like the video. If you did, don't forget to smash the like button and share this video with as many people as you can. Thank you guys, bye, stay safe, stay healthy, and keep watching my videos. Done.